You turn the key, but nothing happens. The car just sits there, completely silent. For a moment, you freeze too. Then it hits you. What's wrong this time? Really? Don't worry, you're not alone. Every driver has faced this frustrating moment at least once in a no crank, no start situation. This is one of the most confusing and frustrating moments any driver can experience because you might start wondering, is it the battery or maybe the starter? And what's even more confusing, where do you even begin to figure it out? Instead of guessing what's wrong, let's walk through a step-by-step guide to pinpoint the real cause of a no crank, no start condition. Before jumping to conclusions, it's important to follow a clear diagnostic workflow. In this video, we'll run a simple, effective sequence of checks, starting from the very first thing every mechanic examines, so you'll know exactly what's causing the problem and what to do next. Number 1, check battery voltage. Always start with the basics. The battery. A weak or dead battery is the number one reason your engine won't crank. Grab a multimeter or a simple voltage tester. If the reading is below 12.2 volts, your battery is likely discharged. But even if the lights come on or accessories work, don't assume the battery is fine. Those systems need only a small amount of current, while the starter requires hundreds of amps. If the battery voltage drops sharply when you try to start, that's a clear sign it can't supply enough power. Recharge or replace it before checking anything else. Once you've confirmed that the battery is in good condition, the next thing to check is your dashboard. Pay close attention to what happens when you turn the key to the on position. Number 2, check dash lights. Once you've confirmed the battery is good, turn the key to the on position and watch your dashboard carefully. Do the warning lights come on as usual? If all the lights are dim or completely off, that means power isn't reaching the ignition circuit, and that alone can cause a no-crank condition. At this point, don't rush to the starter yet. Pop the hood and check your battery terminals and ground connections for corrosion or looseness. Even a slightly loose or oxidized terminal can interrupt current flow to the ignition and starter relay. Clean and tighten the connections, then try again. If after cleaning, the dashboard lights come back on brightly, you've most likely found the culprit, a loose or corroded battery connection. But if the dashboard lights were already normal from the start and nothing changes after checking the battery, it means your power supply and ignition circuit are working properly. In that case, the issue isn't with the main power, it's further down the line, in the starter control circuit. Now you know it's not a total power loss. It's time to narrow it down. Number 3, listen for a click, starter relay, or solenoid. Next, listen carefully when you try to start. Do you hear a click? That small click sound tells you the ignition switch is sending a signal to the starter relay or solenoid. No click at all? Then the signal might not be reaching the relay, which could point to a bad ignition switch, a blown fuse, or even a faulty neutral safety switch. But if you do hear the click and the engine still doesn't crank, it means the relay is trying to work, but the starter motor might not be responding. We'll get to that soon. Before we move on to the next step, hit that like button, drop a comment below, and subscribe to support the channel. It really helps us keep making videos like this. Number 4, check fuses and relays. If your battery and ignition lights check out, but the engine still doesn't crank, the next place to look is the fuse and relay box. Every starting circuit is protected by fuses and controlled by relays. And if just one of them fails, the entire circuit can be cut off. Pop the hood or check under the dashboard to find your fuse panel. Look for one blown fuse labeled IGN, start or crank. A single burnt fuse can interrupt the signal between the ignition switch, starter, relay, and starter motor. Next, locate the starter relay. You can test it easily by swapping it with another identical relay from the same fuse box. If the car suddenly cranks after the swap, you've found your culprit. It's a small, inexpensive component, but when it fails, it can make your entire engine seem completely dead. Number 5, test the neutral safety switch, or clutch switch. Here's a common cause that often gets overlooked. You turn the key and nothing happens. But then you jiggle the shifter a bit and suddenly the engine cranks. That's a classic sign of a neutral safety switch issue. Modern vehicles use this safety interlock to prevent the engine from starting in gear. If you're driving an automatic, make sure the shifter is firmly in Park P or neutral N. Try moving the lever slightly while turning the key. If it only cranks in one specific position, the neutral safety switch is probably misaligned or failing internally. For manual transmission cars, the same principle applies, only through the clutch safety switch. If that switch doesn't detect the clutch pedal being fully pressed, the system won't send a start signal, no matter how much you twist the key. In that case, check for proper pedal travel, inspect the switch for damage or misalignment, and have it tested if necessary. It's a simple sensor, but when it fails, your car can act like it's completely dead. Number 6, check ground continuity. At this stage, you've confirmed that power is reaching the system, but that's only half the story. Electricity needs a complete path to flow, and that means your car also needs a solid ground connection. A weak or broken ground can completely stop the starting circuit, even if both the battery and starter are in perfect condition. That's because every amp of current leaving the battery must return through the ground strap or cable, usually connected from the engine block to the chassis or battery negative terminal. If that strap is corroded, loose, or damaged, the circuit becomes incomplete, and the starter motor simply can't operate. To confirm this, grab your multimeter and test for continuity between the negative battery terminal and the engine block. You should get near zero resistance. If you see high resistance or no continuity at all, clean the contact points or replace the ground strap entirely. A poor ground is one of the most overlooked causes of a no-crank problem, and it can mimic battery failure, relay issues, or even a bad starter. So never skip this step. It can save you hours of unnecessary troubleshooting. Number 7, test for 12 volts at starter. Now that your power and ground are confirmed, it's time to test whether the starter motor is receiving power. With a multimeter or test light, check the large positive terminal on the starter. It should always have battery voltage. Then, while turning the key to start, check the smaller control wire. If you see 12 volts there, but the starter doesn't respond, that means the starter motor or its internal solenoid is faulty. If there's no voltage on that smaller wire when you try to start, the problem lies upstream, possibly in the ignition switch, fuse, relay, or safety interlock. This test helps you pinpoint exactly where the electrical signal stops. Number 8, tap the starter. Sometimes, the simplest test can tell you a lot. If your starter receives power but doesn't spin, try gently tapping the starter body with a metal tool while someone turns the key. If the engine suddenly cranks, that means the starter's internal brushes or solenoid are sticking, a clear sign the starter is worn out. This trick can help you confirm the diagnosis before replacing the starter. Just remember, it's only a temporary workaround, not a fix. Number 9. Scan with OBD-II. At this point, if everything electrical seems fine, but the car still won't crank, it's time to bring in technology. Connect an OBD-II scanner to check for trouble codes. Some codes may indicate issues with the immobilizer, ignition circuit, or communication between control modules. For example, if the ECU isn't receiving the start request signal, it can disable cranking completely as a safety measure. By scanning, you can avoid unnecessary part replacements and find hidden electrical faults faster. Number 10. Verify ECU communication. Finally, make sure your vehicle's control modules are talking to each other. A lost connection between the ECU, BCM, or immobilizer can make your car look completely lifeless. No crank, no start, and not even a single trouble code. Hook up your scan tool and check if these modules are communicating through the CAN network. If there's no response, inspect the fuses that power the ECU, verify proper power and ground at the module, and look for signs of water intrusion or corroded connectors. A disconnected or failed ECU can mimic multiple other problems, so confirming communication is your final but absolutely critical step. So that's the complete step-by-step process to diagnose a no-crank, no-start situation. Following this logical sequence keeps you from guessing and from wasting money replacing parts that aren't actually bad. Always begin with the basics: battery, power, and ground. Then move step by step toward the more advanced checks, like fuses, relays, and finally, ECU communication. By working systematically, you'll uncover the real cause behind that silent engine and fix it the right way. Have you ever faced a no crank, no start issue and found a different cause? Share your experience in the comments below. It might help other drivers too. And if you found this guide helpful, hit the like button, subscribe for more in-depth automotive tutorials, and turn on the notification bell so you never miss the next video.